So now we have the next part in our managerial economics class, particularly chapter 2, and this is the video Q&As from the textbook. And here we are with chapter 2 and Q&A number 1 from that chapter. Assume the following demands and supply functions for avocados. So the quantity demanded is equal to 104 minus 40p plus 20 price of tomatoes, PT, P sub T, plus 0.01 Y, which is income, and supply is equal to, the quantity supplied is equal to 50 plus 15P, and QS and QD are in millions. And what we want to know is how does the equilibrium price and quantity of avocados change given an increase in the price of tomatoes, P sub T, from 80 cents to $1.35 when income equals 4,000. So we have our demand function there. QD is equal to 104 minus 40p plus 20p sub t plus 0.01 y. And we are inserting that $4,000 income into there. And that gives us QD is equal to 104 minus 40p plus 20p sub t plus 40. And that gives us a demand function that where QD is equal to 144 minus 40p plus 20p sub t, which is the price of tomatoes. So that is our demand function when we hold income constant at $4,000. So there's the demand function we're working with. And now we want to take a look at how the quantity demanded varies when the price of tomatoes is 80 cents here and the price of tomatoes is $1.35. So what we're going to do is calculate QD for these for the different prices of the price of tomatoes. So the price of tomatoes is equal to 80 cents and the price of tomatoes is equal to $1.35. So what we do is we put the 80 cents into the demand function. So we have 20 times 80 cents. So that gives us 16. So the demand function is 144 minus 40p plus 16. This gives us a demand function that QD is equal to 160 minus 40p. And we'll do the same thing when the price of tomatoes is equal to $1.35. So we stick the $1.35 into our demand function for the price of tomatoes. So 20 times 135 gives us 27. And when we solve that down, we get that QD is equal to 170 minus 40p. We bring up the supply function, and the supply function was QS is equal to 50 minus 15p, and the equilibrium is going to occur where QS is equal to QD. We set QS and QD equal to one another, so we have 50 plus 15p is equal to 160 minus 40p. All right, we subtract 50 from both sides, so we get 15p is equal to 110 minus 40p. We add 40p to both sides, which gives us 55p equals 110. And when we divide both sides by 55, we get an equilibrium price of 2. We do the same thing with the demand function when the price is equal to, the price of tomatoes is equal to $1.35. So here we have our demand function in that instance. Here's the supply function, and the equilibrium occurs where quantity demanded is equal to quantity supplied. So we set these two equal to one another and solve, and we get the price is equal to $2.20. So our next step here is going to figure out what the equilibrium quantity is. So if we go with our original demand function that was solved down for, we get QD is equal to 160 minus 40 multiplied by 2. So we get QD is equal to 160 minus 80. So the quantity demanded is equal to 80. And we do the same thing for our demand function when the price of tomatoes is equal to $1.35. All right, that gives us a price of $2.20. We place that price in the demand function. $2.20 multiplied by 40 gives us 88. So we have 171 divided by 88. So we get that QD is equal to 83. Moving on to the next one, the Q&A 2.2. When they became available, star length and other GM, which is genetically modified corn seeds, caused the supply curve of corn used for animal feed to shift to the right. If consumer concerns cause the demand curve for corn to shift to the left, how will the before genetically modified equilibrium compare to the after genetically modified equilibrium? Consider two possibilities with regards to the demand curve: little consumer concern and substantial consumer concern. So what we're seeing here is that the development of these genetically modified corn seeds is lowering the cost of production, which is causing the supply curve to shift to the right. The two scenarios we're considering is that there's consumer concern. The first scenario we have to consider is that people are a little bit concerned. Some people might stop buying the product because of their genetically modified. So there'll be a minimal impact on the demand curve versus another scenario where a large number of people have decided that they're not going to buy these products because they use genetically modified corn. And this is considered substantial consumer concern. So we want to compare what's going to be the impact on equilibrium price and quantity if people aren't too concerned with genetically modified foods versus if people have a substantial concern about genetically modified foods. So here we are, and we're taking a look at little consumer concern. And here's our original equilibrium in the marketplace, P1 and Q1, giving us the equilibrium price and quantity for corn. So what we end up seeing is that with the development of these genetically modified seeds, this is lowering the cost of production for the firm. So the supply curve is going to shift to the right. So we see, here's our original supply curve, here's the new supply curve, and this rightward shift of the supply curve is due to the lower costs associated with the genetically modified corn. Now we're going to analyze what happens to the demand curve, and remember, this is with little consumer concern. People are not that concerned, so there will be a very slight impact on demand, and the demand curve shifts to the left. So we have a rightward shift of the supply curve and a leftward shift of the demand curve, and the shift in the demand curve is minimal because there is little concern. And we see that because of this, we see that the equilibrium price falls, but also the equilibrium quantity increases. All right, so just be aware of that. Now, the main thing that we're concerned with is how is this going to compare to what happens when we have a great deal of consumer concern. So when we have little consumer concern, our prediction is going to be the price per pound of corn is going to fall, and that the equilibrium production and consumption is going to increase. Now let's take a look at the scenario where we see a substantial consumer concern, meaning that the demand curve is going to shift dramatically. So with the introduction of the genetically modified corn, we see that the supply curve shifts to the right. So here's our original supply curve. Here's the new supply curve. And we have substantial consumer concern, so the demand curve is going to shift quite a bit to the left, as we show here with demand curve 2. So this dramatic shift in the demand curve from demand curve 1 to demand curve 2 is due to the fact that there's substantial concern. A lot of people are going to stop buying these products. So what's going to be the overall impact of this? We see that the price falls, but we end up seeing that the equilibrium quantity in the marketplace decreases. So the difference between the two is that they both saw equilibrium price falling. All right. So when there was little consumer concern, we saw a fall in the price of corn per pound, but we actually saw the equilibrium quantity increasing. If we take the same scenario, but we have substantial consumer concern, we will see that the price falls even further when there's substantial consumer concern about these genetically modified products. And also there will actually be a decrease in the equilibrium quantity of that product. And here we have Q&A 2.3. If the supply curve is vertical and the demand curve is linear and downward sloping, what is the effect of a dollar-specific tax collected from consumers on equilibrium price and quantity, and what share of the tax is paid for by consumers and why? So here's our scenario. We have a vertical supply curve that is perfectly inelastic, and we have a linear downward sloping demand curve, and this is our equilibrium price and our equilibrium quantity. So we're going to place a specific tax on demanders. And what's the impact of this is going to be is the demand curve is going to shift to the left. And we should also note that the vertical distance between the original demand curve and the new demand curve is going to be the equivalent to that specific tax, that $1 per unit tax. The rationale for this is as follows. If you think about this, if there's an individual who was willing to pay $10 for this particular product, so their willingness to pay was $10. Now the government is going to collect a dollar tax off of them whenever they purchase this item. Their willingness to pay will now become $9 because now they have to include that dollar tax. So now, post-tax, specific tax on this particular product, before they were willing to pay 10, now they're only willing to pay 9 because now they have to take into account the dollar tax. So the highest they're willing to pay after the tax is going to be subtracting off the specific tax that's being placed on that. So what we end up seeing is that the equilibrium quantity remains unchanged because we have an inelastic supply curve, and we see that the price that consumers are paying falls, and that fall is exactly equivalent to the specific tax, in this instance the $1. So in this instance here, consumers do not pay the burden of the tax. The burden of the tax on consumers is equal to 0. Because of the fact that they are paying $1 less than they were previously in the marketplace, which is exactly equivalent to the dollar tax. Excuse me. Also, if we take a look at this from the supply side, if you take a look, this supply curve is perfectly inelastic. It's vertical. That means that the quantity does not change with changes in the price. Quantity is fixed and prices can fully vary. So what ends up happening is, again, excuse me, that the firms are going to be taking less in profits and less in revenues from this product because their quantity does not respond to prices. So because the supply curve is perfectly inelastic, the entire burden of the tax falls upon the supplier.